Hello, Assalamu alaikum, sir. We are from Section G. Our course name is Digital Logic and Circuits. Our group members are MD Tanvir Rahman Tushar, MD Mehdi Hassan Tanvir, MD Rakib Hassan, and MD Tanjidul Haq. Our topic name is Synchronous Binary Irregular Counters. Hello, Assalamu alaikum, sir. I am Tanvir Rahman Tushar. My ID is 20419941. My topic is Synchronous Binary Irregular Counters. Here is our given circular sequence is no repeating number with not any ascending or descending order. Step 1. First we have to observe the binary number of given sequence and step 2 is identifying the number of required flip-flops. So from required sequence and desired design of system, uh, here we can see the maximum value is 9 and 9 can be represented as 1001. So maximum 4 digits are required and the output of the system will be Q3, Q2, Q1 and Q0. Therefore we need 4 JK flip-flop in synchronous connection. Step 3. Counter table. Here filling the present state and next state values. Our first step is present step, that is 0 1 0 0, and next state is 0 0 0 1, and it will be our present state 0 0 0 1. Then from here our next state is 1 0 0 1. It will be our present state again 1 0 0 1, and next state is 1 0 0 0, and it will be our present state again 1 0 0 0, and next state is 0 1 1 1 0, and it our present state. From here it will go back to our first present state 0 1 0 0. Presenter is MD Rakib Hassan. Will discuss about how flip-flop transition table works and how we can be fill up J0, K0, J1, K1, J2, K2, J3, K3 values from using transition table.
Hello, Assalamu alaikum. My name is MD Rakib Hassan and my ID is 20420051. As we are discussing about our topic and which is synchronous binary irregular counter. So here in our sequence our maximum value is 9. So for solve this we need to 4 JK flip flop, and I am here to discuss about how JK flip flop transition table works. So here QP represents present value and QN represents next output value. So here first present input value is 0, and we need same value 0 in output. So we have to input value 0 in J and 0 in K. It will works like a memory, that means no change. And we can also get output 0 by inputting 0 in J and 1 in K, that means reset. Then in next output we need 1 in output, and here present output value is 0. So for this we have to put input value 1 in J and 0 in K. This is set condition. And also we can put 1 in J and 1 in K. This will works like a toggle. Like this here present value is 1 and our next desired output value is 0. So we can put 0, 1 in J and 1, 1 in K. 0, 1 works like reset and 1, 1 is toggle. Lastly, our present value is 1 and our next output value is also 1. So here we need to put 0 and 1 in J, 0 and 1 in J input, and 0, 0 in K input. 0, 0 works like no change, it will work like a memory work, and 1, 0 is set condition. So here we can shorten the JK flip-flop transition table to simplify input value of J and K. And here J value can only be 0, but in K value it can be 0 or 1. So we represent it by don't care condition. Thus we can shorten this table. Our next step is to use this transition table to fill up J0 K1, J1 K1, J2 K2 and J3 K3 values. So for this, first for Q0 we have to check present state value for Q0 and next state value for Q0. So here in present state Q0 equals to 0, and in next state q naught equals to 1. So we need our output value is equals to 1, that is here in second number in our transition table. So we need to input 1 in j naught and cross in k naught. Thus we can fill all the values of j naught, k naught, j1, k1, j2, k2 and j3, k3 values from this transition table. So that's all from me. Our next presenter will talk how we can fill up K-map for these values and then solve them with standard sub expression. Thank you.
Assalamu alaikum. I'm MD Mehdi Hassan Tanvir. My ID is 204200441. I'm going to describe how we can fill up Carnot map for the values which are taken from the transition table and then solve them with standard sub expression. When we fill this Carnot map, we must fill this according to the present state, and there can be several cells with empty condition, and we'll fill that those empty cells. Don't care. We are solving J naught and K naught and solving them with standard sub expression. After solving them, we get J naught is equal to Q3 prime and Q1 prime, and K naught is equal to Q3. Here we are solving J1, K1, solving them with standard sub expression. After solving them, we are getting J1 is equal to Q2 prime, Q0 prime, and K1 is equal to 1. Here we are solving J2, K2 with standard sub expression. After solving them, we are getting J2 is equal to Q0 prime and K2 is equal to Q1 prime. Here we are solving J3, K3 with standard sub expression. After solving this, we get J3 is equal to Q2 prime, K3 is equal to Q0 prime. Our next presenter MD Tanjidul Haq will discuss about how to connecting the output connection in the diagram. Thank you.
Hello, Assalamu alaikum. My name is Mohammad Tanjidul Haq. My student ID is 20420091. Our next step is connecting the output connection in the diagram. From K-map, we have found some of expression. So first K0 equal to Q3, then J0 is equal to Q3 prime, Q prime, Q1 prime. Uh, Here so Q3 prime, Q1 prime first connected with AND gate, and then it directly to connected to Xenor. Then K1 is equal to 1, and then J1 G equal to Q2 prime, Q0 prime. Here again Q2 prime, Q0 prime connected with AND gate, and then it directly connected to J1. Then J2 is equal to Q0 prime, then K2 is equal to Q1 prime, then J3 is equal to Q2 prime, and lastly K3 is equal to Q nor prime. This is our final design of synchronous binary irregular counters.
Thank you everyone. That's all from us.